Hello everyone, this is Sandeep Kumar from Sri Venkateswara College of Engineering. I am giving the presentation on problems on Thevenin's equivalent circuit and the superposition theorem. And this is the definition for Thevenin's equivalent circuit. The equivalent circuit in a voltage source with a voltage VTH in series with the resistance RTH. The Thevenin's equivalent voltage VTH is the open circuit voltage at the output terminal of the original circuit. And this is the definition for superposition theorem. The superposition theorem is said that in any linear bilateral network where more than one source is present, the response across any element in the circuit is the sum of response obtained from each source considered separately. In the constant, all the other sources are replaced by the internal resistance. And these are the examples for the Thevenin's equivalent circuit and for superposition theorem. The problem, it is example for Thevenin's equivalent circuit. The Weinstein bridge in the circuit shown in figure is balanced when R2 is equal to 1200 ohm. If the galvanometer has resistance of 30 ohm, how much the current will be detected by it? When the bridge is unbalanced by setting R2 is equal to 1204 ohm. This is the circuit is given for the problem, and the voltage is 120, and the four resistors, one is 900, another one is 600, another one is 1200, another one is 800. We want to replace this R2 resistor to 1204 ohm and calculate the voltage across the galvanometer and the resistance, volt resistance across this network. And totally we want to find out the current across the galvanometer. This is a circuit is given for the solution, and we want to calculate the voltage across the galvanometer by using the mesh loop, considering this mesh by applying the KVL to this mesh. And this is the equation is obtained by the KVL, and we want to replace the whole components to right side for the finding the VT, and apply the I1 and I2 for this for in this equation, and we obtain finally this voltage 95.8 millivoltage. Next, I am going to find out the resistance across the whole network, and this is the resistance 900 and 600 are connected parallelly with the terminal A, and 1204 and 800 are connected parallelly with the terminal B, or both the resistors are connected serially with each other with the terminal AB. And we want to find out the total resistance by the calculation, and this is the total resistance obtained 840.64 ohm. I am going to design the network by using the total voltage and the total network and the 30 ohm resistance. I am going to find the current across the 30 ohm by applying the Ohm's law. I is equals to V by R, and the total voltage is equals to 95.8 into 10 power 3 minus 3, and total resistance is 840 and the 30 ohm. And finally we obtain the total current is equals to 110.03 microampere. And I am moving on to the next question. This is the question is example for superposition theorem, and this is the network is given for the superposition theorem. In the superposition theorem, we want to find out the current for voltage source separately and the current source separately. Finally, I am going to add the both the currents. Finally, this is a solution for this network. I am going to find the current across the voltage by applying the KVL, and this is the solution for the circuit, and find out the impedance. After, I am going to find out the current by applying the voltage by resistance. Well, impedance is equals to total resistance, means 4 minus J2 plus total resistance are connected in parallel, and total resistance is equals to 6.01 angle of minus 45 degree ohm, and the current is equals to voltage J20 divided by Z impedance, and the obtained current IA is equals to 3.328 angle of 135 degree ampere. And next I am going to find out the current across the current source of 5 ampere. I am going to apply the KVL across the mesh 1 and the mesh 2, and these are the equations are obtained by the both the meshes, and I am going to solve this equation by the method of matrix, and the finally I am got IB is equals to 2.897 angle of minus 23.696 degree ampere. Both the IA and the IB current are opposite direction, so I am going to subtract each other. I is equals to IA minus IB, and final output is equals to 6.11 angle of 114.78 degree ampere. And this is my presentation. Thank you for watching.